Okay, so in this video, we're going to pick up from where we left off with this project, our 5 different classes or Java files we've got kind of dispersed between these 2 different packages. What we're going to look at next is going to be this concept of polymorphism. So to kind of get started on this, we want to take a moment to consider this term polymorphism and what it exactly means. So in a very general sense, this term polymorphism refers to the concept of many forms or many, in this case, many different classes or objects of classes. In a sense, when we're talking about Java or programming languages, we have things like the shape, polygon, rectangle, and circle class. So what we want to consider is the idea for our reference variables, so these different types that we specify here, to be able to reference many different types of objects. Okay, so that's where that idea of many forms comes from. And so to give you a general idea about how this looks in Java and some of the rules that we have to adhere to when it comes to polymorphism, you can take a look at this right here. So we've got our 3 different types of reference variables. We've got a shape, a polygon, and a rectangle. And we've got 3 different types of objects that we want to construct and have these variables reference. So the first one we've got is our shape reference variable. We can see that it is of type shape, and we can see these arrows denoting the different kinds of objects that this reference variable can reference. So when we're talking about shape, this is capable of referencing objects of the shape class. We pretty much understand this much already. But in addition to that, we can also reference objects of the polygon and rectangle class. And the reason for that is because of the fact that we have this hierarchy of inheritance, meaning that because polygon and rectangle inherit from the shape class, we can use reference variables for the shape class to reference objects of either polygon or rectangle. So another way that we can think about this is based on that is a relationship. So we know that our shape, or that our polygon is a shape, and that our rectangle is a polygon, which is a shape. Because of both of those relationships that we're thinking about there, that helps to more accurately or more concisely describe why polymorphism works. In addition to that, we've also got our polygon reference variable, so we got that second line right there. And this is capable of referencing objects of the polygon class as well as the rectangle class, but we cannot use a polygon reference variable to reference variables of the, or to reference objects of the shape class. Okay, so we can't do this in reverse because we know that while a polygon is a shape, it's not necessarily guaranteed that a shape is a polygon. One of the other examples of a shape would be a circle, and a circle is not a polygon. And then on the very last line, we've got our rectangle reference variable, and we can only use this to reference objects of the rectangle class, because again, a rectangle is not, or a polygon is not necessarily going to be a rectangle, and a shape is also not necessarily going to be a rectangle. Okay. So now that we've seen this little diagram right here, we'll go ahead and actually write out a line of code for this. So as part of the example for this, let's start off with kind of in the middle. So we've got our polygon and rectangle. Let's go ahead and create an object of our polygon, or a reference variable for a polygon, and then have that reference an object of rectangle. So I'll have our polygon. I'll use the same naming convention that we saw in this diagram. So I'll go with poly1. This will be equal to a new rectangle. And then for the rectangle constructor, as we can see right here, we need to pass in 3 doubles for this. We have our length, width, and apothem. So for this one, we'll do something kind of simple. We'll do 10, 12, and 4. And so then if we go ahead and compile this and run it, we can then see all the different constructors that are being called because of the fact that we are constructing the object using a rectangle, the rectangles constructor, even though it's being assigned to a polygon reference variable. So we'll come over here, go ahead and compile it, and then we'll go ahead and run it. And then we can see right here at the very bottom, these 3 different constructors corresponding to the fact that we made a call to the rectangles constructor. So you see the shapes, polygons, and rectangles constructor here. Okay, so in addition to the constructor, we'll go ahead and take a look at trying to call some other methods of our different classes. So let's take a look at, say, the getArea method, for example. So for this one, if we look at, say, polygon and rectangle, right now the way that I've got it set up, so we've got polygon with get area that takes a double, and we've got rectangle with a get area that takes no arguments at all. So we've got two different types of get areas, meaning that we're dealing with method overloading in this case. So let's see what happens when we try to access the get area method using this polymorphic poly1 that we have right here. So say the area of the, and for this one I'm going to go ahead and kind of combine the two class names in this description. That way then we can keep track of which one of these print statements corresponds to what. So say the rectangle polygon. The area of the rectangle polygon is plus, and then we'll do poly1 dot get area. Go ahead and save that, and then we'll come over here and let's try to compile this. Okay, so we try to compile this and we run into an error. So our method get area in class polygon cannot be applied to the given types. It was expecting a double, but it found no arguments. So it looks like it was only expecting the get area inside of the polygon class. So even though rectangle has its own version of get area through method overloading, our program didn't even look at this other version of it. It was only expecting the one that takes a double. So when it comes to method overloading, it looks like only the method that is in poly1, so whatever is in the class for the reference variable, that's the only thing that's going to get used here. So let's consider this maybe with method overriding instead. So let's say we remove the perimeter variable and we change this back to being the apothem squared. So we'll say this dot apothem. So save that. And so now what we're going to be doing is we have get area in both the rectangle and the polygon, but instead of doing method overloading, we're going to do method overriding. So now they both have the exact same method signature, and our program needs to pick between the two of them. So right now, since we saw with method overloading, it's using the get area for polygon. The likely expectation is that it's just going to use get area for polygon again. So if it does that, we're going to see 4 squared divided by 2, which should give us 8. Okay. So come over here, we'll go ahead and compile this. And this time around, it did actually compile properly, so it seems that it has in fact used one of those two methods. We'll then go ahead and run it. And right here at the very end, we see the area of the rectangle polygon is 80. And so if we look inside of a rectangle constructor, we're doing length times this dot apothem times 2. And that looks like precisely what we got right here. So we have our length, which is 10, multiplied by our apothem, which was 4, and that's going to get multiplied by 2. So we did 10 times 4 times 2, which gave us the 80. And obviously, if I want to make sure that this is accurate, I should change this to 6. So go ahead and make that little correction. But for the parameters that we used before, 10 times 4 times 2, they gave us 80. So it looks like when we do method overriding, and we have this polymorphic referencing like this, we are actually going to use the get area of the object that we're referencing instead of the reference variable. So a key distinction that we have to make there is that if we're dealing with method overloading, we're going to use it for the reference variable, but if we're doing method overriding, we're going to do it for the object itself. Okay. So then the other possibility that we could consider is, what if, instead of doing method overloading or method overriding, what if we do one where we just don't even have that method in one of the two classes? So let's say we use shape as our example. So shape doesn't even have a get area method, but polygon and rectangle do. So what happens if we do something like creating a shape, so we'll call it shape1, and say this is equal to a new polygon object. Okay, so we'll go ahead and pass into our polygon just a single parameter for an apothem. For this one, we'll just do, let's say, 9. We'll go ahead and save that, and then we'll go ahead and try to access the get area method. So we'll say the area of the, in this case, we'll say polygon shape is plus shape1 dot get area. Okay. So let's go ahead and try to compile this and see what happens. So go ahead and clear this, compile it, And as we might have expected based on method overloading, we see that we have an error right here, cannot find symbol, and it's saying that we cannot find the getArea method. So it looks like in this particular case as well, we were only looking inside of shape to try to find the getArea method, and even though we couldn't find it there, but we could have found it in Polygon, we never even look inside of Polygon to try to find that getArea method. So in this particular case, it seems that by trying to rely on polymorphism, we do at least need to guarantee that the method with the exact same method signature is in both the referencing class as well as the objects class. So a key thing that we want to keep in mind here is that in order to accomplish this, this would mean that we need to implement the getArea method in every one of our classes, but ideally we don't typically really want to have to do that. That sort of defeats one of the underlying benefits of inheritance, which is the ability to just inherit the methods from the parent class. You know, if we try to use these polymorphic references like this, then we're kind of forced to implement the method in the shape class, even though we don't really want to do that. So I want you to keep this in mind. We want to come back to this to address this by introducing a different way that we can actually put the getArea method into our shape class without necessarily having to implement it in our shape class. So that'll be something that I want to come back to a little bit later. In addition to these, so we've seen this idea of having our objects be referenced by reference variables of different classes. We've also seen a little bit about what happens when we try to access a method from a polymorphic referenced object. And the last thing I want to go ahead and introduce as well is going to be what is known as the instanceof operator. So for the instanceof operator, what this is going to be used to do is basically check to see if a variable that we have, if it is referencing an object that is an instance of a particular class. Okay, so what we can go ahead and do is say if, let's say we'll do poly1 for it now. And then we use instance of. So we use the phrase instance of, all is just a single keyword. And so this is going to be an operator. It's a binary operator that takes a value on each side of it. So think of it kind of like addition or subtraction. And what we're going to go ahead and do on the other side is put in the name of a class. So we're checking to see if this reference variable is an instance of, let's say, rectangle. Okay. So the expectation here is that this would be true. Since poly1 references a rectangle object, poly1 would be considered an instance of rectangle. And so what we want to go ahead and do is just have a print statement right here and say this is a rectangle object. We'll go ahead and save that. We'll come over here. We'll compile everything. And also make sure that we comment out this line since that gives us an error. Okay. We'll go ahead and run it, and we can see right here at the very end, this is a rectangle object. So this gives you a pretty good idea of the instanceof operator. Additionally, if we wanted to, we could also go ahead and test it on something like, say, itself, for example, like its own class. So if we use poly1 and we say instance of, let's say polygon this time. So the expectation here is through inheritance, we remember this relationship, a rectangle is a polygon. So because of the fact that poly1 is an instance of a rectangle, it would be a given that poly1 must also be an instance of a polygon. So if this statement is true, then this statement must also be true. So we say this is a polygon object. And then the last thing I also want to go ahead and include is for shape as well. So we could also say if poly1 instance of shape. And once again, through inheritance, because it's a rectangle, it must be a polygon, and if it's a polygon, it must be a shape. So we can go ahead and print that out as well. So say this is a shape object. Okay, so we'll go ahead and save it, run this again, and see these three print statements. So go ahead and clear that, compile everything, go ahead and run it all. And we can see right here at the very end, we get each one of those print statements. So we can say this is a rectangle object, a polygon object, and a shape object. Conversely, if we look at, say, this shape referencing a polygon, we'll go ahead and do one more print statement right here just to demonstrate the case where this ends up being false. So say if shape1 instance of rectangle. So in this particular case, we are now referencing a polygon object. So we know a polygon, if we check to see if it's an instance of polygon, that would obviously be true. And if we check to see if it's an instance of shape, because of inheritance, we know that a polygon is a shape, so that would also be true. But if we check to see if shape1 is an instance of a rectangle, well, not every polygon is a rectangle, so this is not necessarily true, which means that it must be considered false. So we try this. We say system.out.println, line. We'll say, in this particular case, we'll say our polygon is a rectangle. And the expectation here is that this statement will not print to the console because shape1 is not an instance of a rectangle. Shape1 is only an instance of a polygon and an instance of a shape. So if we come over here and let's go ahead and clear this. This list is getting very long. Compile that, run it, and we can see we still have those 3 print statements from before, but we don't get that final print statement. Our polygon is a rectangle. Okay. So at this point, this is going to wrap up the first half of what I want to talk about with polymorphism, where we got to see precisely what polymorphism is. We got to see a little bit about trying to access methods with polymorphic references, and we got to see this instance of operator. The last thing I want to go ahead and talk about briefly for this, that also kind of leads into the next video, is precisely what is going on with the different calls to methods, and why is it that we get different results depending on if it's, if the method exists, if it's overloaded, or if it's overridden. So we've got this assumption. So based on what we just saw, we've got a superclass reference variable that references a subclass object, say like shape referencing a polygon, or polygon referencing a rectangle. So what was happening whenever we called an overridden method? Well, what's going on here is what is known as dynamic binding between our reference variable and our object. So we've got 2 different kinds of binding that occur at different times whenever we are putting together our Java programs. So we've got to deal with things that occur at compile time. So whenever I run the Java command, that's all the stuff that's going on at compile time. And we've also got to deal with the stuff that's occurring at runtime whenever I run the Java command in the command line. And so all the stuff that occurs at compile time, this is what would be known as static binding. So whenever we do static binding, so we deal with situations where the methods are being overloaded, or a situation where the method doesn't exist, we see errors at compile time because that particular instance is what deals with static binding. But when we're dealing with an overridden method, that's where dynamic binding comes in. So with dynamic binding, what we're going to be concerned with now, as we can see right here, the object's type determines which method to call at runtime, and we can kind of see that right here because we have a get area in both polygon and rectangle with the same signature. And so it's not until at runtime when we finally check to see what the object itself actually is, then we go ahead and determine which one of those 2 methods we're going to use. So that's actually figured out at runtime rather than at compile time. Okay. So this is going to wrap up everything for polymorphism. Going into the next video, I want to address this issue with the shape class and how it is that we can go about adding an additional method for get area to this by introducing what are known as abstract classes and abstract methods.